First off, I think you all know our panel, but I'm going to introduce him again. This is Ms. Zeplamasa. She'll talk to you all about this. And Greg Hilgard and Dr. Keel, who have been doing our live astronomy for more years than I can want to count for either any of us. And they're going to talk about all the stuff that you may not have heard about, space-related, because we were all hibernating at home. So I'm going to turn it over to them. Thank you, thank you, thank you.
Space Track has arranged an update for all the news that Space Track people care about that didn't quite make it in because other stuff was taking up all the oxygen. So this will be sort of a high-speed roundup. Here we go. Dateline, low Earth orbit. Only weeks after marking its 31st anniversary in operation and continuing to set new records for longevity of space telescopes, the Hubble Space Telescope suffered a potentially mission-ending failure in a component of its complex onboard processing electronics. After working for nearly 6 weeks, the Tiger team, composed of specialists from the Space Telescope Science Institute, Goddard Space Flight Center, and even retired workers from early in the Hubble program were able to isolate the vault and reconfigure the system to use its still functional backup components. Normal operations have resumed to the delight of astronomers and space aficionados worldwide. Tune in to this network at 7 p.m. Eastern Sunday for our in-depth coverage, anchored by Hubble operations scientist Ken Carpenter. Well, a virtual simulacrum of Ken Carpenter.
Okay, to your mics loudly, please.
Sorry, we were having a behind the scenes
Almost
conversation before the panel.
All right.
Dateline. On board an undisclosed terrestrial ship, the James Webb Space Telescope is about to be shipped from its final test site in California to the ESA launch site at Peru, French Guiana. The details kept under wraps for fear of piracy and ransom demands. It sounds outlandish, but this in fact happened to the structural components of the 15-meter James Clerk Maxwell millimeter telescope en route to Hawaii. And this is where I'm going to editorialize because as written, this is a little bit misleading. So what actually happened with the James Clerk Maxwell telescope was that the structural component for the telescope was supposed to be on a large ship, and for whatever reason, like the boat broke down, so they had to contract through another shipping company. And then that was supposed to go directly to Hilo and start construction. They didn't hear from the ship over the span of a few weeks. And they did some investigation, and they found that the ship went to Holland to pick up some explosives. And then started coming back to the Panama Canal. He got delayed there, probably because they had explosives on the ship. Then the ship disappeared again, presumably to offload the explosives somewhere, in the Pacific. So by the time they reached Hawaii, the ship was late, and so they were going to be charged a late delivery fee. And the captain was not happy about it. He stopped outside of the territorial waters to demand full payment, or he said, "I'm dumping this cargo in the drink."
Oh my God.
And the folks who are, organizing the telescope, who are responsible for that mission, were like, "No, not cool." And they obtained a writ of piracy and had the Coast Guard go and nail it to the mast of the ship and take custody and bring the cargo to Hawaii. So it wasn't like the pirates that we were thinking about that took this. It was like the captain just going rogue.
Still pirates.
Right? It's super interesting.
But I think that still qualifies as piracy because that is exactly how they do it.
Oh yeah, absolutely. I just wanted to give more context because I thought that was but the first thing that I think about are like little pirates going avast, with like cutlasses and trying to take hold of a ship, and that wasn't quite what happened.
And I guess this is sort of a stress relief thing, but some enterprising astronomer did in fact generate an online game JWST versus the Pirates.
I have a link to it in my, oh yeah, that's another thing I should have added to this blurb. Come out at 10 p.m. tonight to hear more about JWST and see the link for the Pirate game.
Dateline, all the twilight skies of Earth. Starlink began launching batches of 60 of its low Earth orbiting internet relay satellites. 1,735 have been launched by now, with mixed reports on reliability of relay service. Astronomers have expressed doubt on how well the system was thought out based on the unexpected brightness of the first batch in the night sky and the open regulatory environment under which they were launched, possibly opening the system up to software failures, causing orbital collisions and debris events. SpaceX has worked to partially mitigate the system's interference with optical astronomy and has now filed applications to orbit a total of 11,914 satellites. Additional enterprises are also competing for the low Earth orbit internet market with their own mega constellations, such as the OneWeb. Is this one of your images?
The right-hand one is yes. So, yes, they were all marching by as bright as the shooter this time.
Yeah, they're quite annoying little objects.
So are you going to be getting a phone on strictly that later in the car?
I really try to not use language like that, and I have avoided being quoted in the LA Times for fear of being dogpiled because I just didn't have room in my life to deal with that.
Yeah, I don't think there's a whole panel worth of conversation for us to have about that particular topic, other than that
Because this is a panel of astronomers.
Yeah,
So
we're certainly very biased on the subject.
we're sort of nearly one end. I see a radio astronomer in the front room might not be even as even-handed as this in describing Dateline, low Earth orbit. China's new generation Tiangong space station began construction with the Chang'e core module and Changzhou cargo ship. 3 crew members have been on board since June 2021. A co-orbital space telescope, Shushan, is planned for 2024, allowing periodic docking and servicing by station crew. Looking up the names, it was slightly confusing because there was a recent announcement that despite the fact that the 2 previous short-duration Chinese space stations were Tiangong 1 and Tiangong 2, the new multi-module station, which is now started assembly, will be known as Tiangong. Good luck Googling.
That's kind of impressive, like the size of this thing, that most people don't even realize is in space. When we think about space stations, we think about the International Space Station and nothing else. There's actually this whole other space station that's being constructed.
And I was able to show it to a class last week, going overhead, and it was first magnitude. Not as big as ISS, but it's plenty big in that spot.
All right, Dateline, elsewhere in low Earth orbit. Full commissioning of the SpaceX Crew Dragon system has allowed complement of up to 11 spacefarers on the station for long periods. This summer, the long-delayed Russian Novka module, a refitted version of the original Zarya module, docked at the station and caused a dramatic day by rotating it through uncontrolled thruster firings. Order was restored after 540 degrees of rotation. So some of you might have heard this story. When it was originally published, they were like, NASA said, oh, there was a rotation of maybe 45 degrees. And then the more they investigated that, they were like, oh yeah, never mind, it went a full 540. It was like the first time that the NASA flight director, Scoville, said that they had a spacecraft emergency. But they did say that the change is really slow, and those on the space station probably didn't notice it, but yeah, it was a little surprising.
As hard as they work to keep the solar arrays pointed solarward, and then somebody just joins on and starts. Apparently it was a really exciting day in Houston,
There's a small X-ray telescope that's bolted to the side of the space station. It's named ICER. And I was just thinking, some of these observations got ruined while this was happening.
Okay, we're slew surfing.
Dateline, New Mexico Spaceport, Virgin Galactic Spaceship 2 made its first passenger flight, famously carrying company founder Sir Richard Branson for brief, precious minutes in microgravity on its suborbital flight.
And then just a day or two ago, the FAA grounded further flights pending investigation because they went outside the airspace box specified in the flight plan. You know, which, kind of one or the other, because, you're making an unpowered descent, it's a thing. But, it's kind of okay with me if there's a little bit closer regulatory attention to private spaceflight. Dateline. The wilds of West Texas. Only days later, the first passenger flight of Blue Origin's New Shepard vehicle made its own suborbital ascent, carrying Jeff Bezos and the Mercury 13's Wally Funk. In fact, simultaneously carrying the youngest and oldest people to have been above the Von Karman line into space. And I guess that 10-gallon hat is so nobody will notice any resemblance to any movie characters.
Dateline, Kodiak, Alaska. Rocket company Astra knows how to test in style. Their latest attempt just 6 days ago resulted in a maneuver pundits are now calling the Kodiak slide. So, with one of its 5 engines failing at liftoff, the Astra rocket performed an unexpected sideways descent off the pad before climbing to an altitude of 50 kilometers. So, while the flight was originally planned to reach orbit, given this dramatic liftoff, I'd hardly call this a failure, especially for a rocket company that's only 5 years old. I think this is a remarkable achievement of modern rocket engineering, that with an engine failure at launch, they were able to clear the pad and then clear the ground and actually try to make it to orbit. Like, that they were able to do this at all after an engine failure at launch is extraordinary. So I don't think this is a failure at all. I think it's incredible.
Suboptimal.
Suboptimal, sure, but amazing engineering.
But
Like,
the control systems just really get the highest reviews.
Yeah.
And Chris Hoffman apologizes, his partner, because he works for Astra, he normally is here, he would have been here, but his partner was not well, so he decided he could not come.
I'm just enjoying the video.
Okay, Dateline, low Earth orbit, microplastics, a scourge in the ocean. Formed by the breakdown of plastic trash in the ocean, these microplastics, smaller than a sesame seed, are harmful to the ecosystem, marine life, and possibly even to humans. Scientists have recently discovered a clever way to track this menace from space. Using an array of 8 small satellites that are used to study hurricanes, NASA's Cyclone Navigation and Satellite System, scientists noticed that microplastics congregated in areas where the ocean's surface was smooth. Scientists hope that such accurate tracking of microplastics will aid in the cleanup efforts for a healthier planet.
Dateline, low Earth orbit. Recent satellite collisions have highlighted concerns over space debris, especially as ever larger constellations of satellites make traffic control a serious issue. Technology tests for cleanup of large debris objects have begun, with the Japanese company Astroscale launching its ELSA-D demonstration mission from Kazakhstan this year. A European consortium is preparing the Removed Debris demonstrator for use at the International Space Station, while an ESA Swiss partnership plans a 2025 launch of the Clear Space 1 mission to capture an upper stage adapter from one of ESA's Vega launches. For a long time, space debris has been like the weather. It did what it wanted, and even before the mega constellations, there were collisions and anti-satellite weapons tests that generated worrisome amounts of debris in low Earth orbit. So any of these steps are welcome, even though these techniques of interception can only address big pieces of debris, not the painful start. With the small debris, people have had ideas like pulsed lasers to ablate material off one side of a piece of space debris, which statistically over time would drop its orbit back into the upper atmosphere. But still by now, does everybody realize that the best way to deal with space debris is to not make it? Eventually there are now standards for, I think it's for all NASA-sponsored flights. You have to have, the mission profile has to include safe disposal of the booster stages. Though, nobody does it with nobody else does it with SpaceX's style. So at least maybe we won't make it much worse.
Right? Dateline, Puerto Rico. The venerable and iconic Arecibo radio telescope suffered significant damage from the passage of Hurricane Maria in 2017. Before it could be repaired, additional failures made a controlled demolition the safest option. While engineers were inspecting the status of the remaining cables of the video drone, the massive receiver structure collapsed into the dish on December 1st, 2020. The Arecibo dish, built into a natural depression in the karst landscape, was long the planet's largest single radio telescope and played a unique role in planetary radar and therefore planetary defense. Advocates for asteroid study, radio astronomy in general, and the culture and economy of the island are encouraging plans for a replacement built on the remaining infrastructure in Arecibo. Due to changes in transmitter and receiver technology, such a facility might take the form of a huge tilting table holding an array of smaller dishes as a phased array. This was devastating for many subdisciplines of astronomy and for the island of Puerto Rico as well, which has suffered a lot of hurricane damage over the last several years. But the unique capability of radar ranging for near-Earth objects is one that there's no plan to really replace right now, and that's bad. So it's really a devastating loss for all of us. Anybody have any other bad news?
I'm okay with something happier.
I think this is the only bad news
Dateline, above Venus, in an historic first. 2 satellites completed a flyby of Venus within 33 hours of each other on August 9th and August 10th. Don't worry, the satellites were never in any danger of colliding. Both missions, Solar Orbiter and Bepi-Colombo, are using Venus flybys for gravity assist to steer the satellites to their final destinations. The Solar Orbiter, operated by the European Space Agency and NASA, will use additional flybys of Earth and Venus to arrive at a position to study the sun's poles. This vantage point will gather never-before-seen data to help solve mysteries about the 11-year solar cycle. Bepi-Colombo, operated by the European Space Agency and the Japanese Aerospace Exploration Agency, is en route to Mercury for its first of several gravity assists around the planet. When final insertion into Mercury's orbit concludes in 2025, Bepi-Colombo will answer fundamental questions about how our innermost planet formed and evolved. In addition to using Venus as a gravity assist, both missions gathered data about the plasma magnetic field around Venus. No word yet on whether they've detected phosphine in the atmosphere of Venus.
Those are so cool. I love those videos.
Right?
You would think it would be easy to get closer, to move closer into the inner solar system, but it is not. Moving into the inner solar system is devilishly tricky, which is why this thing that's trying to get in Mercury orbit has to do all kinds of crazy gravity assists on its way. It's easy to go into the sun, if that's what you want, but
You've still got to kill all that active momentum off, so.
relatively speaking.
Dateline, outer solar corona. NASA's Parker Solar Probe and ESA's Solar Orbiter continue to ease ever closer to the sun, sampling and observing the solar corona and plasma processes. Like ESA's Bepi-Colombo Mercury mission, they use Venus gravitational assist to shrink their solar orbits. This affords interesting chances to observe Venus. and examined the claims of phosphine in its upper atmosphere along the way. Parker had a safe beginning to its voyage toward the sun by setting out when? When is the safest time to launch to head toward the sun? At night. Do I have any shame?
All right, now we begin the Mars extravaganza. Dateline, Martian service in orbit. China's expanding program of planetary exploration scored a trifecta with its first Mars mission. Timeline when? The orbiter deployed the Zhuang lander with its rover, which then deployed a small camera to take multiple selfies on the surface. So, in addition to taking selfies, this primary mission for the rover was supposed to last 90 Sol, which is 90 Martian days, and it did, and it was successful. So in addition to taking a selfie, it also, did other science, like analyzing dunes and rocks that it roved over. It traveled about a distance of 889 meters. And now it's in an expanded mission where it is going to be exploring what could be an ancient ocean floor and gathering data from that. And what it does is it sends data back to the orbiter, and then the orbiter sends data back to Earth for the astronomers to analyze.
You would be forgiven for mistaking this as an image of Sojourner also, right? It looks like China just essentially replicated what NASA did 25 years ago with Sojourner. But think about how much micro technology has improved over the last 25 years, right? This thing has really nice HD cameras, much improved instruments. So even though their base mission was exactly the same, to survive 90 Sol on the surface and move into an extended mission, and it looks remarkably similar, it's a much more advanced little craft and a remarkable achievement. Oh, hey, that's still talking. Dateline, high Mars orbit. The United Arab Emirates' first probe, Amal, which means hope, reached orbit ahead of its companion ships from Earth, providing a stream of data on the Martian atmosphere. Amal joins a fleet of 7 other operating Mars orbiters from NASA, ESA, ISRO, Roscosmos, and the Chinese National Space Agency. This made India and the UAE the first 2 countries to send spacecraft into Mars orbit successfully on their first tries. And it was just a couple years ago when we passed the magical point where now more Mars missions have been successes than failures, historically. So Mars was cursed for quite a while. The curse is broken, it seems like.
Apparently they discovered how to make more satisfactory spacecraft sacrifices to the great ghoul at Mars.
If you look at the images that Amal has taken, they're really spectacular for a small, low-budget satellite, and it's really a great achievement for the UAE as a country that has not been known for scientific endeavors, and so I think this is very good for science in the Middle East. And I hope they continue to put science in the Middle East. It's incredible. A lot of college students also were involved in design and construction of the satellite. So it's really both in the UAE and in the United States.
Dateline, Jezero Crater, Mars. NASA's Perseverance rover and hitchhiking Ingenuity helicopter made another hair-raising rocket-craned landing in July 2020, just downhill from an ancient river delta. Aside from gathering drone video on another planet, the mission has as a key goal collecting samples to be left for a future retrieval mission in partnership with ESA to return for terrestrial lab analysis. This just in, we've received an email in the studio saying, "I'm not dead yet. Who do you think taught Percy to stick that wild landing?" And the oldest ones is still cooler geologically. The return address says something about a Gale crater. Join us for special coverage of both missions by JPL's Kim Stedman and Sarah Milkovich, Saturday at 10 and Sunday at 8:30. Are those still right?
Kim and Sarah, they did a virtual, it's on DCTV. Kim Stedman will be doing her own talk on Mars Perseverance and Ingenuity. And that's Sunday.
Okay, Sunday. Ignore the Saturday, but go to DCTV.
It has been updated properly in the app, I checked.
Okay, well, since there's a whole panel on that, I don't want to say much about it, except that nothing has made me happier and feel more like a kid than watching the little helicopter HQ. It was like my childhood dreams coming true to see this little thing flying on Mars. It's so cool.
And every time they report that it's still going and doing longer things, and one of the early press conferences, they laid out the timeline of when various things were first done on Earth, and then sort of, trying to read the expressions of people at the mission briefings is exactly like this. But I can see it in her eyes. They want to loop that thing before the mission ends. Dateline. Breathtakingly close to Jupiter's magnetosphere. NASA's Juno orbiter continues to probe the gravitational and magnetic fields of Jupiter, incidentally getting close views of its cloud formation using a camera which was originally added as a public outreach afterthought, and in fact for which a lot of the image processing production has been done by the distributed amateur planetary image processing community.
Dateline, back on Earth. JAXA's ambitious 6-year Hayabusa 2 mission to the asteroid Ryugu returned significant samples for Earth-side analysis, some individual pieces larger than 1 millimeter in size. The mission included 3 small rovers on the asteroid's surface and the use of an explosive to sample material newly exposed at the surface. As a mission bonus, the orbiter was redirected to fly by 2 additional small asteroids in 2026 and 2031. So I think it's just so cool. We've got into the space where we're sending spacecraft to other bodies in the solar system, grabbing samples of rocks and stuff from the surface to bring it back to us so we can analyze it in the lab. It's so sci-fi. It's so cool.
In the 50s movies, the ones that didn't even imagine landing a long skinny booster on its tail, they would do all this stuff, but it would all have to have people. So they go to a planet and not really know how to tail at the surface. And this is a thing that just sort of is really flipped on its head, even since planning. When I was a youngster, just the maturity and flexibility of automated remote control, as well as the expertise of the mission control teams. There's astonishing things being done by robots.
We still need to get out there, though.
But not for the first reconnaissance of really dangerous places.
Big man, Captain Kirk.
The images of the surfaces of these things always kind of blow me away, because it's one thing to take an intro asteroid course or a planetary science course and learn there are 2 types of asteroids in the solar system. One of them looks like made out of little bits of rock and debris and loosely held together. It's another thing to see these close-up images and see, look, this is a giant thing that's made up of little pebbles and dirt and loosely held together by gravity. And I think that's really super cool. And to scoop it up and bring it back, it's amazing.
Dateline, Inner Asteroid Belt. NASA's OSIRIS-REx asteroid mission has embarked on its return to Earth, carrying an overflowing sample container after finding that its target Bennu has about the consistency of cotton candy. Speaking of loosely held together. The samples should parachute into Utah in September of 2023. This one, they had a target of 70 grams of material, and apparently because it turned out to be very loose, when the sampling container reached the surface, it just kept going right in until the thrusters pulled it back up. They said it would have gone a couple of feet, they thought. And as a result, when they first pulled it out, they had a big sample. They couldn't quite close the door on the container. So they had to figure, okay, what do we do now to make sure that we don't twist the spacecraft in a way that lets the sample, that pulls all the sample out? So they said, we're going to skip some further operations and just see if we can close this up and send it home. Dateline, Outer Kuiper Belt. After triumphant flybys of the Pluto system and the much smaller and more distant object Arrokoth, the New Horizons probe continues outward. Looking back from its unique vantage point, it gathers brightness measurements of transient Tumia objects which shed new light on the surface compositions. Then, turning outward, it obtained a set of images of nearby red dwarf stars from its distant vantage point. Compared with simultaneous images taken by earthbound astronomers, even as many observatories were closed due to the pandemic, it provided a first demonstration of onboard interstellar navigation. The images also give a striking demonstration of the parallax shift of stars finally looking like all the diagrams in textbooks. It's not a subtle shift. This is a combination of the New Horizons stacked images and our most nearly simultaneous observations from Chile.
Very cool.
So in fact, you can set them up side by side if you can do that. If your natural eye fusion is as bad as mine, you can just let them drift and make the 3D pairing. Son of a gun, Proxima Centauri is just hanging there in front of all those other stars.
That's beautiful. I'm gonna steal that to use in class.
Just such a beautiful visual thing, because parallax measurements, before you can measure it, but you can never show people two pictures taken by opposite sides of the Earth's orbit, where the star goes back and forth against the background the way it does in the diagrams of the textbook. So I predict that a set of images like this is going to be for decades in whatever the equivalent of intro astronomy textbooks ends up turning into.
You'll have to write it, Dr. Keel.
Yeah, that's really incredible. You know, I work in a historic observatory that spent nearly a century as its primary science mission doing parallax observations from the Earth on glass photographic plates. There are 50,000 of these things down the hall from my office, and I've examined hundreds of these plates over the years, and you can put two on top of each other from which there's a measured parallax, and you can see no shift with your eyes at all. Right? It's all in the tiny micro measurements on the plate where the shift is. It's spectacular.
Speaking of parallax. Dateline L2 Halo Orbit, the European Space Agency's Gaia Space Telescope. In fact, a matched pair of space telescopes continues to revitalize an old and to many boring field, astrometry, the precise measurement of celestial positions. With newly possible accuracy and precision, it has delivered distances to millions of stars and motions for billions. This enormous data set, that's not an understatement there, reveals patterns of motion due to the Milky Way's spiral arms, the 3D distribution of dust in much of our galaxy, and even shows the rotation of nearby galaxies. The data collection is expected to continue for years.
And this is another throwback to history. Over on the left is the Pinwheel Galaxy, Messier 33. And the key thing is the vectors it shows, which are the motions due to the relative movements of the Milky Way and the galaxy and the rotation of that galaxy over a period of only a few years. And the Gaia Space Telescope is so precise that it can show which way M33 is rotating. There's history behind this, because a century ago, there were two people at the Mount Wilson Observatory with offices down the hall from each other, investigating opposite possibilities for what spiral nebulae were with the same telescope. One of them you've probably heard more of. They named a big space telescope for it. The other was Adrian van Manen, who was attempting to do just this precise measurement of positions of spots in the spiral arms against stars. And he came to the conclusion that he could measure that the spiral arms were unwinding. And if he could see that happen, it must be somewhere inside our galaxy. The only problem about this conclusion is that the data were wrong. people have gone, you can scan the plates, the motions are not there. So this is like an object lesson in not letting, in trying not to let your expectations influence things. Because if you had to set a microscope crosshair on the center of a star image. And the thing is that Adrian van Manen wrote the book on good procedure in not letting expectations influence it. And also, I tossed in that background image because that was a mosaic we put together during live astronomy last year in lockdown. So, drumming up a little more clientele for that.
Dateline Milky Way galaxy. Old astronomers have used data from the Gaia satellite to discover a break in one of the Milky Way's arms that's closest to the sun. The break, some 3,000 light years long, is the first major structure identified with an orientation so drastically different than the arms. So breaks and spurs are common in other spiral galaxies and probably common in the Milky Way, but identifying them in our own home galaxy is really challenging as we're sitting inside of it. What's all the more extraordinary about this particular break is that it contains 4 of the most famous nebulas in the sky range: the Eagle, Omega, Trifid, and Lagoon nebulas are all inside of this break. These are all 4 of the brightest, most famous nebulas in the northern sky. And they're all inside of this break, not inside of the arm that we thought they've been in since we identified the arm structure of the Milky Way.
So much for like taking a laser pointer and pointing to the Lagoon Nebula and telling students, okay, and here we're already seeing to the next spiral arm, well, no, to the spur that's cutting across, but
for me as somebody who's interested in star formation on large scales, being able to identify this structure of the Milky Way is the most important thing that Gaia is doing. Understanding what our actual spiral arm structure looks like is incredible. It's something that we couldn't do until now, really. It was all kind of a combination of poor data and educated guesswork. And now it's actual data. You can measure the positions of all of the bright, massive blue stars in the galaxy, map out the structure of the galaxy. It's incredible.
Dateline, Northern Atacama Desert. The Atacama Large Millimeter Array, ALMA, a truly international project, continues to deliver astonishing science. Following on detailed maps of the star-forming gas in nearby galaxies and assays of the gas content of galaxies in the early universe has come detection not only of protoplanetary gaseous disks around young stars and gaps suggesting planets, but a single planet surrounded by so much dust that it seems to be forming something like Jupiter's system of moons. Sub-millimeter, it's not just for molecules anymore.
And if you're excited about what interferometry can do for you, just wait until JWST launches and you have an aperture masking interferometry mode on the near-infrared imager and slitless spectrograph instrument. Right, I'm the manager of the URIS team, and that's what launched every
Also, would you tell us more about URIS?
Oh, I can tell you a lot about the URIS if you want to know. The hidden jewel of JWST. Hear more about it tonight at 10 p.m. Oh, okay, it's me again. All right. Dateline, Barnard Star, 6 light years away. Life is looking rough for any inhabitants of planets around Barnard Star. Using the Hubble Space Telescope and the Chandra X-ray Observatory, astronomers discovered powerful explosions from Barnard Star that sent ultraviolet and X-ray radiation into space. At a distance of 6 light years, this radiation poses no harm to those of us on Earth. But further study revealed that planets orbiting around Barnard Star might not be able to retain an atmosphere during such an onslaught. Since Barnard Star is a type of star common in our galaxy, the harsh environments within such systems may stymie the development and sustenance of life as we know it, even for planets that live within the so-called habitable zone, where liquid water could potentially exist on the surface. Future studies of other stars will reveal whether such energetic flares are common. Complementary studies with the soon-to-be-launched JWST will tell us whether planets around these stars do indeed have atmospheres, and whether there are any biosignatures detected in those atmospheres. So we'll be learning more soon. Stay tuned.
Dateline, cislunar space. The 4 wide-angle cameras in NASA's TESS photometric mission continue to scan large areas of the sky, complementing the results of Kepler in finding bright stars with transiting planets and contributing important data in stellar physics. If JWST succeeds in measuring the atmosphere of an Earth analog planet, it will likely be one first discovered using TESS. Complementary data are coming from ESA's KEOPS, focused on a few especially interesting transiting exoplanets. And it's a really cool thing. TESS is close enough to send back all the data. You know, images of, it's essentially 4, I think there are 70mm camera lenses with CCDs behind them. So it covers like 1/24 of the sky at a time. They stare for a couple of months, and then every couple of minutes, an image of those whole pieces of sky comes down. And there are tools to retrieve the postage stamp images, co-edit images, the brightness behavior of individual stars.
Dateline, the quantum realm. Physicists at the Jefferson National Accelerator Facility used a new technique to measure the size of the nucleus of the isotope lead-208. This beefy isotope is known the universe over for having a thick neutron skin, so measuring its size is no small feat. Actually, it's an unbelievably small feat. The neutron skin is about 3 trillionths of a millimeter thick. But that's almost twice as thick as previous estimates of the size of the neutron skin on this molecule, and much lower error bars on the measurement. Scientists can use this measurement to calculate the expected size of a neutron star, and the answer that they get is 20% larger than previous calculations. Quote, "It is remarkable that the physics of systems that vary in size by 18 orders of magnitude are governed by the same equation," said the research team. Okay, I had to squeeze this in here as a compact object person, because this is one of these really cool things that's a direct link between particle physics and astrophysics. We can't measure the interiors of neutron stars very easily. We can't travel to neutron stars, they're all very far away, and making measurements about their interiors is a complex thing. But it's really important for understanding where the dividing line is between a neutron star and a black hole. Understanding the exact point where physics gives up and something collapses to become a singularity is an important topic for understanding all of the fundamental nature of particles in physics. And so while we can't do that for neutron stars directly, measuring this neutron skin in lead-208 provides an exact measurement of the neutron star of the neutron equation of state, which you can project out to neutron stars. So this tells you about the pressure and temperature balance inside of neutron stars using the exact same equation. And so by measuring this isotope, you really do get a measurement for the physical size that you expect for a neutron star given a mass. And so this is actually a remarkable achievement because it's a physical measurement that lets us calculate how big a neutron star ought to be. And now we can see if that's consistent with actual measurements of the sizes of astrophysical neutron stars. And that'll tell you what their interiors are actually made of. Are neutron stars actually giant balls of neutrons all the way down? Do they have significant crusts of carbon and oxygen on their surface that account for a large fraction of their size? Or is the interior of a neutron star actually some kind of quark superfluid or some other subatomic particle that's even smaller than neutrons? So this is really, really cool, I think. And I had to squeeze a particle physics thing in here because this is something that nobody else is going to tell you about. Okay, so we get a Dateline L2 halo orbit. The Spectrum X Gamma SRG from the Russian acronym X-ray Observatory continues its most sensitive survey of the X-ray sky, marking a new phase in Russia's return to space astronomy. Long delayed by a torturous route to launch, it has delivered landmark results on clusters of galaxies, large-scale X-ray emission in our galaxy, and the tidal disruption of passing stars by supermassive black holes in galactic nuclei. So this is an image of the soft X-ray sky stitched together from the Hibernating instrument on the spacecraft, and this is beautiful. Those of us who spend a lot of time doing X-ray astronomy.
Yeah, and notice like those bubbles like right in the center of the image. These things that are going from the plane of the the center all the way up. These are likely so these overlap with what Fermi detected on gamma ray energies a bunch of years ago. And there's some thought that what we're seeing here are relics of past activity where the supermassive black hole in the center of our galaxy was feeding at a much higher rate than it is now. Now, like, just some stuff kind of falls in, quite a bit. But the thought is that perhaps our black hole had a much more active past, and these bubbles are relics of that ancient activity. It's so cool.
I also love that, when we look at the night sky in visible light, right, by far the brightest things in the sky that we see are stars. Almost everything we see with our eyes are stars. And the brightest single objects in the X-ray sky are supernova remnants, black holes, and neutron stars. So nothing that we can see with our eyes directly, they're dominating the X-ray sky.
Dateline, interferometer elements from Greenland to Antarctica. The Event Horizon Telescope team continues to build on its stunning success, producing an image of light bent around the enormous black hole in the giant galaxy M87. First, by using polarization of the millimeter radiation to trace the magnetic fields in the accretion disk around it, and just lately by probing the innermost details of the jet emerging from those near the black hole in the closer radial galaxy Centaurus A. Both observations provide invaluable insight into how jets are formed and launched from massive black holes, an enigma that astronomers are eager to solve. Tune in Saturday night at 10 p.m. for a special report on black hole research, including more in-depth discussion of both of these results.
By Roy Kilgore.
By Roy. Well, yeah,
By Steph.
yeah. This is where I hop in and do make a special guest appearance to Roy's panel, and we'll talk about each of these in a little bit more detail.
That's how panel planning works. It's me saying, hey Steph, I don't want to talk about this. Can you talk about it? You're smarter than I am. Okay. Dateline local space-time continuum. The extraordinarily sensitive LIGO and Virgo gravitational wave detectors are now showing us the final merger signatures of neutron star and black hole binary systems so often that we hear about them on Twitter. There remain interesting puzzles on why these are more massive than the ones X-ray astronomers pick up from their mass transfer process. Especially interesting are a handful of systems in the mass gap between neutron stars and black holes that I just mentioned. Playing with particle physics. Tune in Saturday night at 10 p.m. For our correspondent special update on black hole research. So yeah, this is super cool.
Broadcast time may differ if received too deep in gravitational wave.
Observations of neutron star black hole mergers for the first time. We'll talk more about that perhaps on Saturday night at 10.
Dateline, beyond the galaxy. Mysterious flashes of light, gone within the blink of an eye. So-called fast radio bursts were first discovered in 2001, and their origin has long puzzled astronomers. Lasting for only fractions of a second, tracking down where these bursts come from and what causes them has been an enduring challenge. Progress in unraveling this mystery was made this year with several discoveries. First was the detection of a fast radio burst from within our own galaxy, associated with a class of star called a magnetar, or magnetized neutron star. Additional clues came from a team of astronomers who used the Hubble Space Telescope to study the galaxies where the locations of some radio bursts had been pinpointed with incredible accuracy. By finding that these bursts originated in the spiral arms of these galaxies, but surprisingly, not in the regions of the most intense star formation. They were able to rule out some explanations for their origins. Could these bursts of light be associated with supernova, more well-known cosmic explosions? This explanation seems unlikely, given that the fast radio bursts are not in regions of galaxies where most intense star formation happens. Astronomers say that flares on the surface of magnetars seem to be the most likely cause. They emphatically deny that aliens have anything to do with these things.
I'm a sort of proud academic parent because I noticed this research was, or at least was led by Alex Manns, who's a graduate student first at my graduate institution, but was one of our undergrads at the University of Alabama and heard a couple of early courses. When I went to a meeting once, there was this interesting poster on quasar absorptions. It was going, oh hey Alex, that's what you did in your summer internship. Hi, yeah. Yeah, I mean, I'm going with age makes you more oblivious. The story I'll stick to as long as I can remember it.
Dateline lower orbit. More hubbub about the Hubble constant. Recent observations by the Hubble Space Telescope have confirmed the conundrum for cosmologists across the country. Actually, across the world, but I just wanted the alliteration. Using measurements of surface brightness fluctuations in nearby elliptical galaxies, astronomers were able to measure the Hubble constant, the rate of expansion of the universe. This method produces a similar result to other techniques used in the local universe, like supernova, technically supernovas, 73.3 kilometers per second per megaparsec, while not introducing some of the biases of those techniques. It's a completely independent method of distance measurement of the Hubble constant in the local universe. This number stands in contrast to the lower values of around 67 kilometers per second per megaparsec measured in the early universe, a disagreement known as the Hubble tension. Is Hubble's constant not so constant after all? Or does the rate of expansion vary from place to place in space? Stay tuned. So I loved this result when I came across it in the news. This is something that you guys may have heard about. There exists this kind of controversy about the value of the Hubble constant, which is that whenever we measure it in the local universe, we get one value, and when we measure it in the early universe, you get a different value that's lower. And the error bars just keep shrinking on both of these numbers, and this is another completely independent measure of distance to galaxies, and therefore the Hubble constant in the local universe that agrees with the other methods. So it means that those methods are not flawed in their methodology. There really is this tension between the two measurements that we're going to have to figure out. And it's a weird thing about the universe that we live in. I also love this for the technique that was used in this case of measuring surface brightness fluctuations in the galaxies. If you're like a data person and are really interested in image science and analysis, ask me about this later because it's a really cool technique, but I don't want to bore everybody with explaining it because there's a lot of details in it. It's really cool.
That's the way it is. Or if you don't like travel time, that's the way it was. Tune in later for our correspondent special reports on some of these late-breaking events.
Questions, anybody?
I just didn't know much about what's going on with Venus and phosphine, so I just was wondering, I didn't know how to move on that, so I was wondering what's up with that.
There was sort of widely reported controversy a year and a half ago where data both from the post-piracy James Clerk Maxwell Telescope in Hawaii and the ALMA ring in Chile showed evidence for a detectable amount of phosphine with an E9I, is that the right one, in the upper atmosphere of Venus. And like every other chemical funny thing running through the solar system, people, ooh, is that a biomarker? We can't. And the people who did detections work with atmospheric chemists doing actual simulations of the reaction chains. There was not a straightforward way to get the amount of phosphine implied by the observations. But you know, if you put microorganisms up there, the difference. So that brought on the particular interest.
Thank you.
And people are still, I think, differing on whether that measurement was as good as they thought from further analysis. The instruments weren't really optimized for it. So if there was any transition and possibly they could look forward to spacecraft flight, I think that'd be.
You're always reading in the mainstream media spectacular stories about exotic exoplanets. But as an informed layman, it just seems to me that the distances involved, the subtlety of the variations in the observations these speculations are based on, it just seems to me it climbs out on a major limb. For example, they'll say that the atmosphere of this exoplanet is composed of this, or this exoplanet has grains of glass, or this exoplanet has a 100-mile deep ocean, or is a core made out of diamonds. What aren't really the limits of our present observational capability for exoplanets around other stars? In other words, how far can you go out where you can actually confidently believe that there might be some juice in these speculations?
I'll start, but other people can certainly chime in. For many of these stories you're reading about, they are based on very detailed observations that astronomers have done, where they can say with pretty high confidence that they've measured specific molecules in the atmosphere, or they've been able to really measure how dense the planet is, and if it's made up of like carbon is really that dense, well then maybe get the diamond core. So that's kind of where some of those extrapolations come from. But the people who study exoplanets do a ton of work, really what they say, getting to the noise floor of the observations, just understanding in excruciating detail how well they are able to understand noise in the detector to pull out signals to be able to measure something with pretty high confidence. So when it comes to, they've measured this molecule in that atmosphere, generally they're pretty secure about that because they've done so much work doing very careful analysis, trying to think of all the noise properties that could exist. And there's a lot of work going on now in doing that type of analysis for future JWST observations to really push it even to like lower limits. I see someone with the hand. Is it?
Just to comment about the fact that keep in mind also that what you're hearing is always filtered through the journalists and stuff like that. And there's a boring prediction and an exciting prediction. They'll go with the exciting prediction instead.
Right. So the comment was like what we hear is filtered through journalists. So the way that they talk about it is going to be. They'll take a result that in a science paper sounds like, okay, that's kind of interesting, and talk about it in very flowery terms.
I have quite a lot of thoughts about the journey from paper to press release, and I have some fun stuff that we can talk about during some downtime in live astronomy specifically about that. I talk about that in one of my classes that I teach. So yeah, that's a very important point that astronomers don't write the headlines, right? And titles of papers are generally pretty boring.
And the headlines are generally not written by the person who wrote the news story.
That's true.
I didn't make my question clear. It's basically, how far out can we go with the current state of the art so we can confidently believe assertions about this planet, this star has a planet.
Okay, so
40 light years.
Well, so specifically about atmospheres, it's less a question of distance away from us as it is distance of the planet from its star. All of the detections of anything in the atmospheres of planets are very, very hot planets. They're things that we don't have in our solar system. They're much closer to their stars than Mercury is to the sun, because that's where you can do those kinds of observations with the current technology that we have. So JWST will be able to do this for planets that are farther away from their stars, that for systems that are starting to look more like our solar system. But like, we can't do this for an Earth or super Earth that's at an Earth-like distance from its stars, and regardless of how far away the thing is from us. If it were happening at Proxima Centauri, we couldn't do that right now.
There was a word you used that gets into the reporting business. Super Earths. If you call it a sub-Neptune, people aren't nearly as interested. But in many cases, you are equally justified from what we know now, which in most planets, the best we can do is mass and radius. And that's pretty good because that gives you density. But yeah, something a certain size with a certain density, a certain range, it could be like an overgrown Earth, or it could be like an undersized Neptune, and with the very deep hydrogen atmosphere and icy core. We obviously have very different emotional reactions to those. We do better where, with the planet passing in front of its star, you can watch the tiny absorption that its atmosphere produces, and there are really interesting detections of atoms and molecules there. But we can only detect certain ones. And there's a second way that exoplanet astronomers hate clouds, because a high cloud layer in an exoplanet's atmosphere makes it almost impossible to figure out what the atmosphere is made of, because you don't see the light that goes through the dense part of the atmosphere that would pick up the signal from absorption. So they sort of get one more flat spectrum null signal and still have to publish it.
Well, thank you.
A couple of big cities down there.
NASA did it a lot. They had some pretty spectacular crashes
NASA
back
did
in
it
the
a lot in
launch.
the 50s and early 60s.
Where they didn't have to wait for anybody to push the button.
Yeah, that's true.
So yeah, I don't know what the procedures are in Kodiak, but
Well, it's a fairly remote spot,
Yes.
so maybe, you don't have to worry.
I think they have a wide range around there. I mean, they're on an island.
Yeah.
So I think they probably have a pretty wide range.
Yeah.
And I consider her, and I think I remember that it actually was terminated by the range safety officer because it was not going to reach orbit, it was going out of control. But even for a range safety officer, it has to be pretty cold-blooded. Watching that, my ranges might be going, well, I've not seen this.
Apparently, there's a different view of it where you can see the rocket pass through a fence before it goes up.
So y'all talked about how the Hubble constant might not be constant, and there might be bubbles in the Hubble constant. What would cause these bubbles to form? Has there been any theoretical speculation on that?
Well, one thing is almost all histories of the universe will have the Hubble constant change with time. But that's already taken into account in the calculations. The question is, okay, if we are in a less dense than usual billion light year patch, that will locally change the expansion just because of the density. People have worked counting galaxies to see if that makes sense. Every once in a while, somebody looks at data in different directions to say, are we sure it's the same in all directions? And then everybody who's been raised on the cosmological principle will hold up silver candlesticks and go, unclean, unclean. But yes, somebody needs to check on this. And of course, there are a lot of theorists who are really interested in new physics, physical processes that we don't know about that would have operated over cosmic time. Dark energy, dark.
What is that?
My question is slightly different. Imagine you have a section of space out there where the Hubble constant is different imagine you have a section of space where the Hubble constant is different from the surrounding section of space. How would you detect that?
If we're in the middle of that section, we would see a change in the Hubble constant that we measure between us and things farther and farther away. That couldn't just be accounted for by gravity and dark energy. If it's farther away, the better and better independent ways we have to have distances, the better that would work, because you could then look for a relationship between redshift and distance within a patch of space that has a different slope than the surrounding. And there are places we see that anyway. As galaxies are falling into clusters of galaxies affected by their gravity, you can actually see ripples in the redshift behavior of the galaxies. So it's the sort of thing you look for, but without a more obvious cause.
Well, anyway, thank you.
Anybody else? Well, then let's thank our three panelists.